Hello guys, welcome back to my channel. So today's topic is biosynthesis and catabolism of catecholamine. So firstly, what are the catecholamines? So catecholamines are of three types. Catecholamine neurotransmitters are three types, that is adrenaline, noradrenaline, dopamine. It is also called as nephrine, epinephrine and norepinephrine. So we have to study in this topic biosynthesis, how they are synthesized in our body, how they are stopped. Catabolism is nothing but metabolism or termination. So biosynthesis of neurotransmitters or catecholamines. The biosynthesis takes place in the adrenergic, dopaminergic neurons, in the CNS, in sympathetic neurons, in ANS and the adrenal medulla. So various enzymes which are responsible for the biosynthesis are tyrosine hydroxylase and dopa decarboxylase, dopamine beta hydroxylase, phenylethylamine, N-methyl transferase. So these here tyrosine hydroxylase, which is addition of hydroxyl group, and decarboxylase means removal of carbon dioxide, and dopamine beta hydroxylase, in beta position the hydroxyl group is attacked. And next phenylethylamine. Here the methyl groups are substituted at amine position and ethanol position. Next, the first starting of the synthesis of catecholamines is where is the phenylalanine in liver by the hydroxylase enzyme. It converts into tyrosine. So by its name we can write the structure phenylalanine. We know that this is benzene. Here it is known as phenyl. Aniline. Aniline is an amino acid of it containing carboxylic group and amine group. So when this alanine is attached to this amino acid, by name itself we can say that it contains acid group and amine group. So when the phenyl ring is attached to the amino acid like alanine, so we can write its structure like this: CH2 CHCOH and NH2. It is known as phenylalanine. So coming to the biosynthesis, the basic ring is phenyl attached to the aniline. So this is called as phenylalanine by the hydroxylase enzyme. Phenylalanine hydroxylase. This is the enzyme. It converts into tyrosine. Just here hydroxyl group is attached, and next the same acid structure has been written. This is called as tyrosine. It is also an amino acid. And next coming to here the enzyme is tyrosine hydroxylase. Hydroxylase is nothing but the addition of hydroxyl group, we know that. So here third position one of the hydroxyl group is attached. CH2 CH double bond and NH2. Here this group is removed, nothing but carbon dioxide is removed. Here tyrosine hydroxylase means addition of hydroxyl group. Here decarboxylation. We can write this name 3,4 dihydroxy dihydroxy phenyl ethylamine. 3,4 dihydroxy phenylamine. And coming to the enzyme dopa decarboxylase. Decarboxylase means removal of carbon dioxide. They write the as the same structure without carbon dioxide. This structure is called as dopamine. Here dopamine beta hydroxylase, addition of hydroxyl group in beta position. Functional group adjacent carbon is called as alpha, and next to the next carbon is called as beta. Here we can write the structure. Beta position, there is a addition of hydroxyl group. You can say it as noradrenaline. Next, here the enzyme is phenyl ethanolamine. This is phenyl ethanol amine N-methyl transferase. And in the SAM is nothing but S-amino adenosine methionine. You can write the structure OH. CH3. Here methyl group is substituted, so it is named as adrenaline. This is the complete biosynthesis of the catecholamines. Here dopamine, here noradrenaline and adrenaline are key. So now coming to the in detail of with the help of this matter. So here we taken L tyrosine gets hydrolyzed into L3,4 dihydroxyphenylalanine L-dopa by the enzyme tyrosine hydroxylase. This is a rate limiting step in the biosynthesis. The step takes place in the cytoplasm of the neurons. So we can see this in the synthesis. Here this step takes place in, we know that, phenylalanine liver, and this steps takes place in cytoplasm of neurons. And coming to the second step, dopa decarboxylase causes decarboxylation of L-dopa to form dopamine 3,4 dihydroxyphenyl ethylamine, and this dopamine formation takes place in the cytoplasm of neurons. It is also same place. And next, dopamine in the cytoplasm is transported into the storage vesicles of VM82, and where it gets hydrolyzed by the enzyme dopamine beta carboxylase to a noradrenaline. A storage vesicle, where the storage vesicles are present in synapse. We know that synapse is synaptic vesicles. These are the storage of neurotransmitters. Storage vesicles in synapse, post pre-synapse. Next, in the adrenal medulla, noradrenal gets converted into the adrenaline. noradrenaline gets converted into the adenine, where it converts in adrenal medulla by the enzymes is adenosine methionine and phenylethanolamine N-methyl transferase. So coming to the catabolism of catecholamines. The actions of the catecholamines can be terminated through the catabolism of metabolic transformation. In this process, particular enzymes changes the structure of the catecholamines so that they do not interact with the adrenergic receptors to produce the effect. So termination is that nothing but stop the actions of catecholamines. There are two types of major enzymes which are involved in the catabolism. That is nothing but MAO, monoamino oxidase, and next COMT, catechol orthomethyl transferase. MAO is present in intraneurons and extraneurons. When coming to monoamino oxidase is also of two isoenzymes, CNS and which is present in CNS and peripheral tissues, MAOA and MAOB. Monoamino oxidase produces oxidation and along with the deamination of a variety of catecholamines and phenylamines. So taking the catecholamine is nothing but noradrenaline. Here it when it undergoes monoamino oxidation degradation or catabolism or termination. So here deamination is nothing but removal of amine group. So it forms 3,4 dihydroxyphenyl glucoaldehyde. Here aldehyde group. When removal of amine group and addition of oxygen group. So 3,4 dihydroxyphenyl glucoaldehyde. Next coming to COMT. It is a cytoplasmic enzyme and causes the methylation of 3-hydroxyl group of catechol ring of the neurotransmitter with the help of the isoenzymes. So it causes methylation. Methylation is nothing but addition of methyl group in third hydroxyl group of catechol ring. So coming here, the catecholamine is noradrenaline by giving the numbering 1, 2, 3. Here methyl group is substituted. So simply we have to substitute the methyl group and write as it is the same structure. So here normetanephrine, its name is. In above cases we only saw about the noradrenaline. Here coming to adrenaline also. So when noradrenaline undergoes COMT, we know that normetanephrine and MAO, it forms 3,4 dihydroxyphenyl glucoaldehyde. In adrenaline, whereas adrenaline at MAO, monoamino oxidase, here removal of methylamine and as well as oxidation takes place. So the same product is formed in this 3,4 dihydroxyphenyl glucoaldehyde. And when coming to the adrenaline in COMT, catechol orthomethyl transferase, it converts into, just simply we should have to attach here methyl group. So it is named as metanephrine. When it goes into MAO degradation again, this compound again goes to MAO degradation, and it is also normetanephrine and metanephrine undergo degradation. It forms as 4. So giving numbering 1, 2, 3, 4. Simply first 4-hydroxy. When oxygen is attached to the methyl group, it is named as methoxy. We know that 4-hydroxy 3-methoxy glucoaldehyde. Its structure is glucoaldehyde structure. So by this we completed the catabolism and biosynthesis of catecholamines. Simply we can know that what are the catecholamines: adrenaline, noradrenaline, dopamine. So this synthesis is done, but we should have to terminate. So that's why called as catabolism. Catabolism is nothing but termination or stoppage of this the particular neurotransmitters. Thank you. Thank you for everyone.